In this video, we will explain how the solution set of some linear systems can be viewed as lines and planes. Let's think about this system. x1 minus 3 times x2 equals 0. This can be viewed as a system with m equal 1 equation and n equal 2 variables. We know how to graph this line. In this case, we can pick some points. Let's say x1 and x2. And let's say this is x1 and this is x2. If x1 is 0, then x2 is 0. It goes through the origin. And if x2 is 1, then x1 would be 3. Then it goes through 1, 2, 3, the point 3, 1. Then this is the line. Now let's see what is the solution set. When we think about just one equation, this can be considered as a good system. In this case, the basic variables is just x1, and free variable would be x2. Then I have to solve the basic in terms of the free, and I get this. And then the solution set would be this set. X1 is 3 times x2, and instead of the free variable, I just write x2 such that x2 is a real number. This is the solution set. But we can write this solution set in this way. I can take the x2 away, and then we have 3, 1, and then such that x2 is a real number. When we think about this, we notice that this solution can be viewed as all the multiples of the vector 3, 1. We have 1, 2, 3, 1. For example, when x2 is 1, then we get this vector. When x2 is 2, then we get twice that vector. We get twice that vector. When x2 is 1/2, we get 1/2 of the vector. When x2 is -1, we get this vector. And when x2 is -2, we get this vector. When x2 is -1/2, we get this point. And then depending if x2 is positive, we get all the points in this semi-line. And when x2 is negative, we get all the points in this semi-line. And when x2 is 0, we get this point. Notice that we have, geometrically, we have the same solution, the same graph. Let's do another example. What happens if we have this equation? x1 plus x2 equals 2. I forgot to say that in this case, when we are describing the line in this form, we will say that 3, 1 generates the line. Sometimes we say that 3, 1 is a direction vector. For the line. Okay, let's continue with this example. In this case, we can pick 2 points to graph the line. And we can say that if this is x1 and x2, then if x1 is 0, x2 is 2. And if x2 is 0, x1 is 2, then the line goes through these 2 points. This is the line x1 plus x2 equals 2. Now let's write the solution set. To write the solution set, we decide what are the basic variables. In this case, basic variable would be the first variable that shows up in the equation. Here is x1 Again, the free variable would be the other one, which is x2. Then we solve for the basic in terms of the free, and we get 2 minus x2, and therefore the solution set would be 2 minus x2 comma x2, such that x2 is a real number. We can rewrite this set in this form. We can write it as 2, 0 plus x2 times negative 1, 1. You can see that when you do this operation, you get exactly this, such that x2 is a real number. Notice that we can view this line in this way. First, when x2 is 0, then we are at the point 2, 0, which is this point 1, 2, 2, 0. And then what happened when x2 is equal 1? When x2 equal 1, we are at the point 2, 0 plus negative 1, 1. Notice that the point negative 1, 1 is negative 1, 1. This is the vector negative 1, 1. And this is the vector 2, 0. And when you add this vector with this vector, you have to move it. And then you will end up here, in this point here, in the point 1, 1. Then this is what happened when x2 is equal 1, you end up here. When x2 is 2, then you will be doing this sum. That means that you will be adding to the vector 2, 0, 2 times negative 1, 1, 2 times negative 1, 1 is this vector, and then you will end up here. When x2 is 1/2, then you will be adding the vector 2, 0 plus 1/2 of this vector. 1/2 of this vector is here, then you will be ending here. Then in general, if x2 is bigger than 0, you will be getting all the points in this semiline when x2 is 0. And a similar argument when x2 is negative. Let's see what happens if x2 is negative 1. When x2 is negative 1, this means plus negative 1 times negative 1, 1, which is 2, 0 plus 1, negative 1. But 1, negative 1 is the opposite of this vector. This is 1, negative 1. And when you add this vector with this vector, you end up here. And when x2 is negative 1/2, you will end up here. When x2 is 2, you will end up here. And then in general, when x2 is any real number, you will get this line, which you will see that is the same line as this one. We will say that in this case, the vector negative 1, 1 is the generator vector. And we will call the point 2, 0. We'll just call it a point in the line. Notice that the generator vector generates this line. It generates this line. When you think about all the multiples of negative 1, 1, then you get this line, and our line that is the solution of this system, in this case the system is just one equation, 2 variables, is a line that is parallel to this line generated by the vector negative 1, 1. We also call this vector a direction vector. Let's do another example. What happened if we are in R2 and we consider the equation x2 equal 3? In this case, we know that we can take points that satisfies the equation. essentially the equation is saying please pick x2 to be 3, but we can take x1 whatever we want. We have 0, 3, or we can have like 2, 3, then we have 1, 2, 3, and here we have 1, 2, 3, and then this is the line. It's a horizontal line. Notice that if I want to write the solution for this, what is the basic variable? Basic variable would be x2, and the free variable is everything that is not the basic. Then it will be x1, and then we need to write the basic in terms of numbers and the free variable, but this is already written like that. And then the solution set would be x1 is free, then instead of x1 I write x1, and instead of x2 I write the expression. Then I have x1 3 such that x1 is a real number. Then we have that we can write this in this way. We can write it as 0, 3 plus x1 times 1, 0, such that x3 is a real number. Then we can see that this is then we can see that this line is constructed in this way. We can think about the point 0, 3. 1, 2, 3. This is the point 0, 3. We can think about the direction vector 1, 0. And essentially, when x1 is 1, then I'm not here at this point. When x1 is 0, I'm here. If x1 is 2, I'll be adding 2 times this vector, which gives me this. And when x1 is negative 1, I'll be here because negative 1, 0 is here. And when I add this vector with this vector, I will end up here. And then the line would be this line. Here, remember, the 1, 0 is going to be called the direction vector, or the vector that generates a parallel line. Notice that the vector 1, 0 generates this line, which is parallel to the line that we are describing. Notice that using the same principle, we have that x1 plus 2x2 minus x3 equal 4. And let's suppose that we have x2 minus x3 equal 1. Then we notice that this classifies to be a good system. And we notice that the basic variables are x1 and x2, and the free variable is just x3. Then I have to write the basic in terms of the free, and then I will be writing x1 as, sorry, I have to start with the last equation. x2 is equal to 1 plus x3, and then for the first equation, when I move one equation up, I have to use the information that I have gotten from this equation. Then it says x1 plus 2 times x2, but x2 is 1 plus x3 minus x3 equal 4, and then I have x1 plus 2x3 minus x3 equal 4, and then this is 4 minus 2. I finally get that x1 is 4 minus 2 is 2. This is plus x3, then it would be minus x3. Then the solution set would be this set. Instead of x1, I write 2 minus x3. And instead of x2, I write 1 plus x3. And instead of x3, since x3 is the free variable, I just write the free variable. And then this is such that x3 is a real number. We notice that this can be written as the vector 2, 1, 0 plus x3 times negative 1, 1, 1, such that x3 is a real number. Then if you want to visualize the solution set of this system, essentially this is the solution set of this system, and then this solution set is essentially like this. This is x1, x2, x3. You have the line goes through the point 2, 1, 0, 2 for x1, 1 for x2, and 0 for x3. It goes through this point and is parallel to this line, the line of vectors that are parallel to this. Negative 1 is here, 1 for x2 and 1 for x3 is parallel to this line. Then this is the vector negative 1, 1, 1. This is the line that is parallel to that vector. And this line that we are considering, let's draw this in blue. This line is the line that goes through this point and is parallel to this point. Then this line is the line goes through that point, parallel to this. Then this is the line. When you think about this vector here, this vector that starts here and ends there, this is the vector negative 1, 1, 1. Okay, then here we have the interpretation of the solution of this system as a line. In this case, this is the direction vector. And this is a point that belongs to the line. Right? This is the point that belongs to the line. This is the point 2, 1, 0. Let's say that this is a point in the line. And this is the direction vector. Let's do another example. Then let's think about this problem. Find a point in the line and its direction vector. For the system x1 minus x2 plus x3 equal 4, and let's say 2x3 equal 1. Then in this case, this is considered to be a good system, and therefore we can decide what are the basic variables and the free variables. The basic variables would be x1 and x3, and the free variables would be just x2. Then I have to write the basic in terms of the free. From here I get that x3 is equal to 1/2. I replace this information in the other equation, and then I get x1 minus x2 plus 1/2 equal to 4. And therefore I have that x1 is equal to x2 plus 4 minus 1/2, which is just x2 plus 7/2. Then the solution set is going to be x1 is x2 plus 7/2. X2 is free, then x2 is just x2, and x3 is 1/2, such that x2 is a real number. Then we have that I can rewrite this in this form: 7/2, 0, 1/2 plus x3 times 1, 1, 0, such that x3 is a real number. That means that the direction vector is the vector 1, 1, 0, and a point in the line, point in the line would be 7/2, 0, 1/2. One observation is that this method works in general, not only when we have three variables. Let's suppose that we have the following system. Let's suppose that we have x1 minus x2 plus x3 minus x4 equal 2, x3 minus x4 equal 7, and let's suppose that we have 3x4 equals 6. Then we have that this is a good system, right? And the basic variables will be x1, x3, and x4, and the free variable would be x2. Then we write everything in terms, we write the basic in terms of the free. We start with the last equation, and then we have that x4 is equal to 2. And if x4 is 2, then we have that x3 is 7 plus x4, which is 9. And then x1 minus x2 plus x3, which is 9, minus x4, which is 2, is equal to 2. That means that x1 is equal to x2 plus 2 plus another 2 minus 9, and that means that x1 is x2 minus 5. And then the solution set would be x1, x2 minus 5. x2 is the free variable, and I write x2. x3 is equal to 9, and x4 is equal to 2, such that x2 is any real number. Then in this case I can rewrite this like -5, 0, 9, 2 plus x2 times 1, 1, 0, 0, such that x2 is a real number. Then we have here that the direction vector is 1, 1, 0, 0, and a point in the line is -5, 0, 9, and 2. Then here, even though for us it's very difficult to visualize R4 because all of this is happening in R4, we can imagine that there is a point -5, 0, 9, 2. This is the point in R4, and we have this another vector in R4, which is the vector 1, 1, 0, 0, and essentially that line, which is the solution of that system, is the line that goes through this point and is parallel to the line produced by vectors that are parallel to this line. Then essentially you move this vector here, and the line is all these points that are of the form this point plus multiples of this vector. Then anytime we have that there is only one free variable, regardless of how many variables we have, that is geometrically aligned. One free variable means that we are dealing with a line. Now let's see what happened when we have two free variables. Let's do one example. Let's consider the system x1 plus x2 plus x3 equal 4. This is a system of equations. In this case, there is only one equation and there are three variables. This is the number of three variables. And this is one equation. In this case, this is a good system, and then the basic variable is x1, and the free variables would be x2 and x3. Then the idea is to write the basic in terms of the free, and then we have x1 would be equal to 4 minus x2 minus x3. That means that the solution can be written like, as said, we open the braces. Instead of x1, we write 4 minus x2 minus x3. And here, instead of x2, we write x2 because x2 is free. Instead of x3, we write x3 because x3 is free. And then such that x2 is a real number and x3 is a real number. We can rewrite this in this form like 400 plus x2 times negative 1, 1, 0 plus x3 times negative 1, 0, 1, such that x2 is a real number and x3 is a real number. Then essentially, let's suppose that we have that this vector is the yellow vector, this vector, and this vector here is the green vector. Then when you consider, let's forget about this part by now. When you consider that x2 and x3 are 0, then essentially you are at the origin. Here is my origin. But when x2, I'm forgetting about this part, when x2 is 0 and x3 is 1, x3 is 1, that means, let me say that, remember that this is the green vector and this is the yellow vector. And then I'm saying that when x3 is 1 and x2 is 0, then we are here at this point. If x2 is 1 and x3 is 0, x3 is 0, that means that we are here at the end of this point. What happened when x2 is equal to x3 equal 1? Where are we at? What is the sum? Then essentially we are doing this vector plus this vector. Then we are ended up here in this point here. This vector plus this vector, this vector plus this vector, then it would be this point here. Then, and actually we notice that if x2 and x3 are positive, then you will get like every possible point in this quadrant that is here, like everything that is in this part here. What happened if x2 is positive and x3 is negative? When x3 is negative, essentially you are flipping this vector and you are getting everything in this quadrant here. For example, x2 minus x3, sorry, this vector minus this vector. We are considering the case x2 equal 1, x3 equal negative 1. What point do we get? This is x2, but now this would be the yellow minus this vector would be here, and then the sum of these two vectors would be this point here. And then in general, when x3 is negative and x2 is positive, we are getting everything that is here. And when both of them are positive, we're getting like this quadrant here. When both of them are negative, then we're getting like everything in this quadrant here. Let me try to type that. In general, here we have the space, and we have these two vectors. And then when I consider, notice that this part here, something that can be written like this, is a linear combination of the two vectors. And then when the weights, these are called the weights, when both weights are positive, then you get anything that is like in this quadrant. But if the weight for this vector is positive and the weight for this vector is negative, that means that you will be getting everything that is like in this quadrant. And if both weights are negative, then essentially you are getting everything that is in this quadrant. And finally, if this weight is positive and this weight is negative, you'll be getting everything that is in this quadrant. Remember that this doesn't have to be like the XY plane or the YZ plane. It's just the plane that rests on these two vectors. In this case, we're going to call these two vectors the generators of the plane. And the reason is because this plane may be the same plane that is generated by these two vectors. That means it could be that this plane is the plane generated by these two vectors. And when you have two vectors, what I mean by the plane generated by those two vectors is the plane that rests on those two vectors. And we're going to be calling this the 4, 0, 0, a point in the plane. Okay, let's do another example like this. We have an equation like x2 minus x3 equal 1. And let's suppose that we are considering x1, x2, and x3. Then in this case, what are the basic variables? The only basic variables is x2. And what are the free variables? In this case, the free variables are x1 and x3. Then we have to write the basic in terms of the free. Then we write x2 equal 1 plus x3. And then for the solution set, we write, instead of x1 is free. That means that we just write x1. Instead of x2, we write 1 plus x3. And instead of x3, since x3 is free, we write x3. And such that x1 and x3 are real numbers. Then I can rewrite this in this form: 0, 1, 0 plus x1 times 1, 0, 0 plus x3 times 0, 1, 1. This may be the challenging part, to realize that this can be written like that. Please practice this procedure such that x1 and x3 are real numbers. Then essentially this is going to be a plane, and then the generator vectors are the vectors 1, 0, 0 and 0, 1, 1, and a point in the plane would be the point 0, 1, 0. Maybe it's worth pointing out that anytime we have two free variables, you are solving a system and you end up with two free variables, then geometrically that set is a plane. And regardless of how many variables you have, let's do another example. let's suppose that we have the following system: x1 minus x2 plus x3 plus 2x4 equal 1. And let's suppose that we have x3 minus x4 equals 7. We can see that this is a good system. And then we can decide what are the basic variables and free variables. We have that the basic variables are x1 and x3, and the free variables would be x2 and x4. Then when we have two free variables, let me just type that, write that. Anytime we have two free variables for a system, its solution is a plane. Remember that we also have that anytime we have one free variable for a system, its solution is a line. In this case, let's see what are the generator vectors and a point in the plane. We have two free variables, that means that we have a plane, but let's see what are the generator vectors. We solve for the basic in terms of the free. We start with the last equation, and we have that x3 is 7 plus x4, and then we replace that information into this, and we get x1 minus x2 plus x3, but x3 is 7 plus x4 plus 2x4 equal 1. And then we have that x1 minus x2. Here I have 3 times plus 3 times x4 equal to 1 minus 7. Move the 7 to the other side. And then I have that x1 is x2 minus 3x4 minus 6. Then the solution set would be, instead of x1, I write x2 minus 3x4 minus 6. Instead of x2, x2 is free, then I just write x2. Instead of x3, I write 7 plus x4, and instead of x4, x4 is free, I write x4, such that x2 and x4 is a real number. Then I can rewrite this solution in this form. And remember, this may be the challenging part. I can rewrite it as negative 6, 0, 7, 0, plus x2 times 1, 1, 0, 0, plus x4 times negative 3, 0, 1, 1, such that x2 and x4 is a real number. That means that the generator vectors are the vectors 1, 1, 0, 0, and the vector negative 3, 0, 1, 1. And the point in the plane is the point negative 6, 0, 7, 0. That means that the way to visualize the solution set of this system in R4 is we think about these two vectors, 1, 1, 0, 0. say that this is a vector in R4. And we think about the vector -3, 0, 1, 1. And we think about the plane that rests on these two vectors. And we also think about the point -6, 0, 7, 0. This is the point -6, 0, 7, 0. And this is the two vectors that generates the plane. Then essentially the solution of that system is this plane. It's the plane that is parallel to this one and goes through this point, and essentially is this plane here. Please do these problems.